Hi, my name is Jim Toogood, and this is the demonstration video for Comp3015 70% coursework. So, starting off in the Scene Basic Uniform H, the things we have added since the 30% are the initialized shadow, and if we look, we've got some extra variables as well, like the shadow width and height, some new models and meshes, the light thruster, some new textures, and the jitter functions. Moving on to our main C++ code now, you can see we are defining the shadow map size as 3000 here. We are defining the samples here and the jitter map size, the radius for that. And here we are defining the models and the meshes and the textures. Moving on to init scene, we are calling our initialized shadow functions and our build jitter texture functions. We are defining our shadow bias. Here we load the models and the textures. Here we assign the textures to their shaders. We define the model transforms. Here we assign how many lights the system has and the variables for the lamp light. Init scene FBO hasn't changed since 30%, so we'll skip that. Going on to init shadow, we create the frame buffer objects for the shadow FBO. Then we move on to the depth buffer texture. Then we define the border. And finally, we check to make sure everything has initialized correctly. Here we compile all our shaders. Here is the update. So this section has not changed since 30%, so I will skip that. But here we are assigning our variables to the lights. This has changed slightly because we are no longer using Bling Fong shading. We're now using full PBR. Here is where we handle the shadows. So first of all, based off the moon and sun intensity, we decide which light between the moon and the sun should be the one currently casting the shadows. Then once we've done that, we orient the light thrustum towards that light. We then set its perspective and define the light PV using the shadow bias and the projection matrix and the view matrix. And then we pass those needed variables into the shader. Next, we move on to render. So our first pass is the shadow map. So this is where we render the scene from the point of view of the light and use that to determine the shadows. And when we do this, we pass a true variable into render scene objects. We will see why in a minute. Then our second pass is just the regular pass where everything is rendered. And here we pass in false. And finally, the post-processing pass, which is the same as before. Going on to render scene objects, as we can see, we are passing in a shadow pass pool. This is useful because it means we don't need to render everything on every pass, because a lot of the information for rendering is unnecessary on the shadow pass. For example, we don't bother assigning materials or textures during the shadow pass, except for models where the texture has transparent parts. For that, we do keep using the texture to allow the shadows to not be casted for the transparent parts of those objects. Instead of using the variables we were using before, we are now using material roughness and material metallic. And here we have the jitter functions, which were imported from the lab code with minimal changes. Moving on to the shaders now, the scene FBO shaders and the skybox shaders have not changed since 30%. However, the basic uniform shaders have. If we look at vert, the main thing that has changed here is we are passing in the shadow chord and calculating it from the shadow matrix. Moving on to the fragment shader here, this is where the majority of this coursework takes place. First of all, we define the constant pi needed for calculations later. Here we pass in the light data, including the directional and point data. That is actually being used correctly now, unlike in my 30%. That was a mistake I made back then. Here we get the material data, which includes the alpha, the roughness, the metallic, and the albedo for any scenarios where the texture for a model doesn't exist or can't be found. And here we are passing in all the needed variables from our main code. Next is PBR. Here are the four helper functions. We have the GGX distribution, which controls the specular highlight shape based on the surface roughness. Next, we have the GGX Schlick geometry, which approximates shadows and masks based off of geometry and roughness, and the self shadows. Next, we have the Geometry Smith, which combines the view and light oculation for specular attenuation. And finally, we have the Schlick Fresnel, which controls angle-based reflectivity. Going on to the main PBR function now, we are using Cook Currents PRDF PBR. Starting off by defining the lights and the radiance. Here we are normalizing the position for the directional lights and defining the attenuation for the point lights. Next, we are defining all the needed variables such as n.l and n.v that we need for the main PBR calculation. And here we make that calculation using our helper functions from earlier, as well as the provided material values to calculate the specular, diffuse, and metallicism and roughness. And then we combine that all and return it into the final PBR value. Next is our get shadow function, which controls the shadows of the scene. So first we define our needed variables, and then we check if the fragment is within the shadow map. And here we do the initial PCF sampling to improve the quality of the shadow, especially around the edges. And here again, we do a second set of sampling to increase the quality of the edges of the shadow. Moving on to the main function, here we check if we are using a texture. If we are, we assign that texture to the base color. If not, we assign the albedo to the base color. And we also check for the image's alpha values. Next, we check for a normal texture. If there is one, we assign it. If there isn't, we just use the default value. Next, we see if the current pass of the shader is the shadow pass. If it is, we define the cutoff for alpha pixels that we want to cast shadows, and then we return, because everything after this is not needed to be calculated in the shadow pass. After that, we define our camera distance and our fog factor, and set the variable for our shading color, and then we iterate through each light. If it is the main light casting the shadow, so either the sun or the moon, depending on the time of day, we calculate the shadow and mix the shadow with the shadow strength. We combine all of that with the PBR value to get the full shading color of the scene. We then add on an ambient factor to stop dark areas from becoming too dark. We combine that with the fog color to get the final color, and we assign that to our fragment color. I will now show the code running. So as you can see, our scene looks quite nice. It's got some trees and a lamppost, a house, and this metal box to show off the metallic values of the PBR system. As you can see, the sun is setting now, so we'll see in a moment that the shadows will fade out and then fade back in to being casted by the moon instead. And as you can see, because the moon is a weaker light than the sun, the shadows are much weaker. And we can also see the light being cast by the lamppost here, shining off the metal box and the other objects. And we can also control the day and night cycle using keyboard inputs. So I can set it back and move it forward again.